Afternoon, everybody. Welcome to What's Your Data Path? This is a series of webinars with data scientists and people in a variety of professions and walks of life who work with data, as well as other tools to learn more, to offer you, the audience, opportunities to learn more about careers in data science and related pathways. And this series is to help people learn about how data, really, that's the theme, infuses almost every workplace today. My name is Jo Louie, and I am at the nonprofit organization Education Development Center, or EDC, which is based outside of Boston in Massachusetts. I am the director of Data Paths, which is a multi-year project funded by the state of Massachusetts to promote interests and skills in data science among students in grades K through 16 throughout the state. And you can learn more about the Data Paths project through our website, which is accessible through the QR code on this slide. Next slide, please. So the Data Paths project is providing an array of professional learning opportunities and curriculum materials to help teachers integrate more data science practices into their current teaching. We're also developing an online career hub, including a suite of resources to help students learn about data science careers. This webinar is one in a series that we are holding this spring as well as next fall to talk with a wide range of people working in an array of fields who use data intensively in unique ways in their work. For those of you who are attending live, our goal is to inform and potentially inspire, to share information with young people about potential careers that use data. We are also recording this session and aim to place on our project website the whole hour-long webinar, as well as clips that people can share with students in classrooms or in out-of-school settings. Next slide, please. So here's our agenda for the next hour. We have an exciting lineup of guest speakers who will present about themselves and their work in total for about 40 minutes. I'll first introduce Charlotte Dungan, who is the Chief Learning Officer at the Mark Cuban Foundation. She will say more about herself and her work. She's here today with several student alumni of the Mark Cuban Foundation's Student AI Bootcamp. And Charlotte may say a little bit more to introduce the students. We welcome all three of them, Srinithi, Fakar, and Milana. Welcome to all of you. After they speak, we'll have a brief Q&A session with the presenters, and then we'll open it up to take Q&A with audience questions. So just some logistics. All participants are muted during this webinar, but you can use the chat feature to talk with other attendees. If you have questions for the speakers, please submit those through the Q&A box located in the Zoom control bar, which should be at the bottom of your screen. I also want to acknowledge Jen Stiles. She is a member of the Data Paths team who is managing the slides and the technical aspects of this webinar behind the scenes. So next slide. And so yes, now let's turn to our speakers. I will turn it over to Charlotte. Why don't you take it away?
Thanks, Jo. I appreciate you having us here today. I am here from the Mark Cuban Foundation, and I'll just tell you a little bit about us. First, we want to talk about 3 levels of AI education. And the reason we're talking about AI is because AI is a layer on top of data. It allows you to take a very large data set and pull answers out of it. You can do that in a way like LLMs, where you are getting text that comes back based on an answer that you give, or you can process scientific data or spreadsheet data in a way that helps you find patterns in that data. And that's why we talk about AI with data, because they tend to go hand in hand. A lot of schools right now are teaching this level of AI literacy, which is just like this technology exists and how to be safe. There's a second level of like a single application or a single problem that's being solved, and you sometimes see that in science classrooms. But our program teaches a third level, which we call AI agency. That's that third level where a student knows when, how, and why they should apply or not apply a certain technology. And I just want to show you a brief other tool. This is a CTE reference for teachers. It's a paper that is talking about how to apply this in CTE classrooms. And I want to show you page 58 in particular, which has these levels of AI. So if you're feeling overwhelmed by this whole space, start with literacy. We're not expecting anyone in K-12 to get to mastery, but you might move through these levels of AI education, knowing that there's a way to build on that. And there's some pretty good descriptions on page 59 and 60. And then 61 has this sort of pathway of, foundational learning, beginning to integrate into your classroom, then selecting what tools and resources are appropriate. And that's where we'd like to see students end up. So going back to my slides here, I just want to say that's where we are, is trying to help students go beyond literacy, which is typically what they receive in schools. And so I just want to help you know how you could upskill as a teacher from that very basic to a larger understanding. All of our teacher programs are completely free. Our teacher boot camp, we run August through May. It's a once monthly 60-minute hands-on, 80% active learning, social activity. We had over 900 teachers sign up this past year. We interact with all of them. We look at what you create. We want you to create things directly for your subject. We can help you. We start with student conversations and policies for your classroom, and then talk about like what's meaningful for you. And we work across the curriculum. So we have art teachers, gym teachers, we have school counselors, as well as those STEM science and math teachers. So no coding required. Come where you are and we'll help you to upskill. We also have a more intensive teacher fellowship that is highly selective. It is paid, so we have a $1,000 stipend. This application is open now. We do prioritize high school teachers from low-income schools and within 120 miles of our student boot camp locations, but apply from anywhere. If you don't get selected for the fellowship, you can move into the boot camp directly. These are our teacher fellows right now. They meet more often. They also create what we call a Beyond Building Impact project, which we help support and fund. So some of our teachers are presenting at NAF, some are teaching or presenting at the National Math Conference. We have a group participating at um, a local state level conference, and we want to make sure that we share out your work. So these are our flagship teachers. Finally, you can see sort of the journey. They do create a project that we help them build, and it's really impactful. We also have a teacher newsletter, so if you're interested in learning about AI over time, please do join and sign up for our newsletter. It's free on the website. All of our programs are always entirely free, and we think that great education begins with you. We're so excited to potentially support you. The students that you're meeting here today are from our student bootcamp program. We try to focus on identity and belonging, building that interest in AI and STEM careers. All of our programs are designed to be a very low floor, high ceiling. So if you don't know anything about AI or computer science, you'll find a place here. But you can see from these student projects that they tend to take them very far. And so I'm excited for you to meet these students today. We do teach the basics of AI from LLMs and prompt engineering all the way to career exploration, mentoring, and then using and generating all kinds of new projects. They are related to workforce pathways and careers. I also wanted to pause here with these, they're coming up soon. If you're a K-5 teacher, I recommend Primary AI. That is at the University of Indiana. And if you're a secondary middle school teacher, look up the daily curriculum at MIT. If you're a high school teacher and you want to use data in your science classrooms, please look up the CODAP platform. That's Concord a Concord platform. You can look up those words. And then finally, if you're looking for data science, I recommend Data Science for Everyone. They have fantastic free webinars for teachers. And also, if you are looking for a little bit more technical education, Processing Foundation has resources for elementary, middle, and high school, including a YouTube series called Coding Train and machine learning for online ML5.js. So just want to make sure that you have options for those. And then we also have a partnership with DataCamp. If you are a teacher or a high school student and you want to earn free certifications in all kinds of data careers, we can teach SQL Server. You can get industry level certifications related to data. All you do is scan the QR code, fill out the brief form. We will set you up with an account. We will not steal your data. We will not otherwise share it in any way except to help you create these accounts. And that is, we have 1 million free licenses on DataCamp, and we would love for all the students and teachers in Massachusetts and beyond to have the opportunity to learn. Truly, this is just a labor of love on our part. I literally just import these and help you get these accounts, and they're good for a year to earn certifications. One of our students here has earned a certification on that platform, I know for sure. So as we wrap up, our teacher boot camps are everywhere nationwide. There are many of them. And we also have an alumni program. So the students you're about to meet are from our alumni network, and they continue to learn with us after a boot camp until they graduate from high school. So they receive newsletters, they attend virtual events like this one, they network with professionals, they learn to become public speakers, and that's why they're here with you today. They also participate in outreach activities with other students, and they meet with my team to help us give feedback and help us co-design our curriculum. So we really have started thinking of ourselves as a youth empowerment organization, not simply a workforce preparation or other type of AI education, but really helping these kids move forward in their young adult life. So we also finally have systems thinking for district leaders. Very briefly, just so you know, we have a policy activity that helps you think across workforce, higher ed, and your what your students need, and think about the different levers and complexity that move forward. And so we have this session that we can run for free for your district as long as you have 5 people to participate. We use a dashboard to look at AI literacy, trust in the community, innovation, morale of teachers, fairness for digital equity, what this would cost you, how it would change the employment in your system, and like the vulnerabilities that come with deploying AI. So we help you think through those things. And if you want to know more, here's how you can contact me. But now I'm going to turn it over to our student presenters. We're going to begin with Sriniti, who is going to walk you through a project that she built and how her school also helped her on the path.
Thank you so much, Charlotte. Okay, so hello, my name is Sriniti Sharia. I am a 12th grader from Corona del Sol High School in Chandler, Arizona. I have earned 11 IT certifications, the most in my school district, including data analytics, computational thinking, Python, and Java. I have also taken 2 computer science classes, which is honors computer programming and AP computer programming, and I am my school's first IT intern this year. So I did my research through the Scene Research internship at Arizona State University with my mentor, Dr. Kong. And something that I'm really excited and passionate about is about the AI integration in healthcare, specifically in things like immunotherapy and neuroscience, which has been unexplored for the past decade. And I attended the Drive Time Tempe Bootcamp because I really thought of AI as a buzzword and I did not know enough about it, and I wanted to learn more. And there's my LinkedIn for reference. Okay, so a little bit of background information about cancer biology. My research was on colorectal cancer, which is a type of cancer in the lining of the colon and the rectum. Most common type of tumor that grows within this cancer is the microsatellite cancer tumors, which have low mutations in the DNA, so the immune system cannot easily detect this type of cancer and doesn't think that there is anything wrong with that person. And So because of that, immunotherapy, which relies on the immune system and boosts it in order to help a person survive, does not work for them. So the only treatment option that they're left with is chemotherapy. And there are a couple of drugs that are used for chemotherapy. And the first one and the most reliable one so far is Folfox. And what Folfox does is that it breaks the mutated DNA and then it repairs it back up so that the tumor DNA, the mutated one, does not spread. And another type of drug that is used in chemotherapy is Folfiri. And what that does is that it stops the DNA from making more copies of itself and spreading the tumor even more within the body. And both of these can be used with combination with another type of drug, which is called BEV. And what BEV does is it stops the blood vessel growth within the tumor. So it stops the blood supply for the tumor and basically stops it from growing anywhere. And another type of therapy that is really upcoming, but we do not have enough data about, is bacterial therapy. What that does is it takes bacteria like Salmonella, which don't need oxygen to survive, and it puts the drug onto that bacteria and sends it to the centers of tumors where there is no oxygen. And that is also the place that chemotherapy can't reach, and puts the drug there so that it can help relieve the cancer and treat it more better than chemotherapy would. But the problem with that is that we haven't had enough information and it hasn't been approved in clinical trials. But so for that, what I did in my research was I used a scoring-based system where I gave points depending on features of the patients that had the cancer. So if the patients were in stage 3 or 4, they got some points because this is the optimal time for bacterial therapy to work. And depending on the tumor, the mutation rate and count, they all got points for that. And for my data, I got it through CBio Portal, which is an easily accessible database. And then it is de-identified data, so there is no names or anything like that. And for my specific research, I used around 1485 patients, real data, and it gave me the sex, the mutation count, how many samples there were, the age of the patients. And I used this. And then what I did with that data was I processed it through a programming language called Python. Python is a very uh, complex and cool type of language. And what it does is helps us visualize the data and understand patterns that are in the data set that we wouldn't be able to easily find ourselves. And it has different packages built inside of Python that can help us do a variety of different things in terms of taking the data, and then we can make it into an algorithm that can basically learn the patterns from the given data and apply it to some unseen data that we won't know about. And what Matplotlib does is that it basically graphs the data that you give it. And third one that I have is pandas. What it takes is that it takes data in terms of rows and columns, and it processes that data and makes sure that all the data is standardized and in the same format. And what NumPy does, lastly, is it takes words and it converts it into binary or some numbers that are much easier to do calculations with instead of words that we can't really use just by itself. So this was some of the data that I created or visualized from the data set, from the Genie data set that I showed. So most of the data that I had was from patients that were in stages 3 and 4. And the mortality rate was also highest in stages 3 and 4 due to the increased amounts of mutations and other types of lack of the immune system that you have as you grow older and you are in the later phases of the cancer itself. Okay, so this is where the AI and the machine learning component of the project comes in. So what I did was I created a random forest classifier, which is a type of machine learning models that takes a lot of trees that make decisions, and then it makes one final prediction from those trees. So every tree gives its own answer, and then we average out about 100 trees and find out one answer, and then does this 300 different times. And what I used it for was to predict whether the patient would survive and what are the chances that the patients would survive and what is the best course of treatment for them specifically. And when it averages it, it reduces the mistakes and prevents the data from getting any bias in the calculations. And basically, we just vote on the best tree with the best treatment. So specifically, this is what a tree looks like for my model. So one of the questions that I asked first was, what's the cancer stage? And the optimal cancer stage for bacterial therapy, for example, would be stage 3 or 4. And then from there, we saw whether they have tumors, whether they have liver metastasized, and what they should consider. And at the end, it gives the probability depending on what kind of drug that they used. So this was just an example of my specific project. And this is the official project that I had, and it was called Using AI to Predict Colorectal Cancer Treatments. And the goal for my project was to build a machine learning model that can predict the best drug for their individual therapy and evaluate the probability that they have to survive and whether they would be a candidate for bacterial therapy for the future, since we don't have enough data or information to know for sure whether they should be used for that or whether it would work on them. And I was mentored by Dr. Ray Kong, and I was in the ASU Scene program, and I used scikit-learn for it, the random forest classifier model, and the area under the curve evaluation, and a rule-based system for the bacterial therapy portion. So how AI helped me on this was it automated the analysis of around 1,100 patients, and it predicted their treatments and which one would work best for them by finding patterns in the data that was given to the model itself. And the data was from patient records, their chemotherapy, and what happened where either they were dead or they were alive. And that was the data set that I used. And I think AI could potentially help with making oncologists have more personalized treatments for the patients. And it could also potentially improve survival outcomes for a disease that affects about 42,000 Americans a year and is the third leading cause of death in the world. Okay, so this is the area under the curve prediction model how accurate my model was basically. So what this graphs is it graphs the false positive rate with the true positive rate. So what that means is it checks whether the model is actually able to predict it correctly or how many times it's wrong. If you were to flip a coin and just note down whether it was true or false, we would have a probability of about 50%, which that is the dotted line right here. And my model did better than that and had more positive rate than the negative ones because it works about 68% of the time and it identifies the correct treatment for the patient and their survivability 68% of the time instead of the 50 we would get by just randomly guessing. And one of the most important takeaways I had was that the age, the amount of mutations, and the cancer stage were the three most important things that affected a patient's survival and what kind of treatment that they had. With age, the immune system definitely starts to take a hit, and having a lot of mutation means that the tumor spreads a lot more into one's body and is harder to treat. And obviously, the stage as it grows creates more mutations and tumors along the way, which is not super treatable like it would be at an earlier stage. And this was the predictive model. So what it did was it recommended the treatment, and then it showed the probability of survival and the bacterial therapy score depending on what they put for different fields. So I'm going to just demonstrate that for a moment, sorry. So right here, what I did was I changed the numbers a little bit and I put a huge mutation count and I put the age as 30, which is relatively young, and then I ran my code. And this is the output that it gave me. So for them, FOLFOX would work the best because FOLFOX breaks the DNA and it repairs it, which is something that we'd want to ideally do for a young patient with a lot of mutations so that the mutation doesn't create a lot more of it. And since they're at a younger stage, the probability that they survive is about 79%. And they were eligible for bacterial therapy as they got a 3 out of 8 and the point system that I created based on my literature review. And lastly, for my conclusion, I said that the model achieved a 68% accuracy, and it was better than randomly guessing. So I would say that the model was successful. And the model took into account the age of the patient, the mutation counts, and the cancer stage, and those were the strongest predictors for whether a person would be able to survive and what treatment would be best for them. And my rule-based system successfully flagged the patients for bacterial therapy candidates, but we don't have enough information to fully concretely say that it would work on them or they would be successful. And the next step would be to definitely use a bigger data set and add more specific mutations and features like the BRAF mutations. And I would refine my bacterial therapy scoring as I would get more data about what makes a patient more eligible. And I would definitely check with doctors and oncologists to make sure that this model really works. And yeah,
Thank you
thank
so
you.
much. That was great. So you can see the possibilities of what a high school student can do with the right supports, giving those classes. I want to turn it over to our next student now, Fakar, I think. Oh, Milana, are you next? Fakar is next. Yeah, okay, great.
Thank you. All right. Today, I want to talk about how artificial intelligence is becoming an important part of biomedical research, especially in drug discovery. Traditionally, finding new drug candidates has been a slow process built on trial and error. Researchers often have to test tens of thousands of compounds, and most of them end up failing. What AI changes is the ability to narrow that search early using computational tools to predict which molecules are actually worth investigating. That shift is what makes AI so useful for tackling real diseases, including Parkinson's. To give some context for why this interests me, my name is Dilfakar Kasim, and I'm a 12th grade student at Harmony Science Academy in Dallas, Texas. I attended the Mark Cuban AI Bootcamp hosted at the Dallas Mavericks in 2024 because I wanted to understand how AI could be applied beyond general technology. I was especially interested in healthcare because that's where the impact feels much more direct for me. And that experience pushed me towards exploring how machine learning could actually support scientific research. From there, the bigger question becomes why AI is so valuable in this space. The main reason is scale. Biomedical research involves massive amounts of data, whether that's molecule structures, protein models, or experimental results. A human can analyze some of that, but not efficiently at a large scale. AI allows researchers to process that information much faster and identify problems that would otherwise take far longer to uncover. Because of that, it becomes possible to focus on high probability candidates instead of just testing everything blindly and seeing what sticks. That idea became more concrete during the boot camp. In the healthcare track, I worked on a project where we trained the model to detect cancer and gliomas using imaging data. That was one of the first times I saw how AI could recognize meaningful patterns in biological data. It wasn't just theoretical, and it showed me that machine learning could be used to assist in medical decision making along with analysis. That naturally leads into the concept of machine learning itself. Instead of manually evaluating every possibility, a model learns from existing data and uses that to make predictions about new inputs. In drug discovery, that would mean learning from known compounds and known interactions, then predicting which new molecules might behave similarly. That predictive step is what allows the process to scale because it reduces the number of candidates needed to be tested in detail. Once those candidates are narrowed down, another method comes into play, which is molecular docking. While machine learning helps decide what to look at, docking helps evaluate how those molecules might actually interact with a biological target. In my project, that target is the MOAB enzyme, which is involved in dopamine breakdown in Parkinson's disease. Docking stimulates how a molecule fits into the enzyme's active site and estimates how strong that interaction would be. It's not a final answer, but it does provide a strong computational approximation. Of course, both machine learning and docking depend entirely on the quality of the data being used. The models rely on molecular structures, protein structures, chemical properties, and reference data from experiments. Without that foundation, the predictions wouldn't be meaningful. So even though AI is the main tool, the accuracy of the process comes from combining those tools with reliable scientific data. With that foundation in place, my research project focuses specifically on Parkinson's disease and the MOAB enzyme. I use safinamide as a reference point because it's already a known MOAB inhibitor. That gives me a baseline for comparison. Instead of starting randomly, I can evaluate whether other compounds behave similarly or potentially better in terms of binding. From there, the goal becomes more specific. I'm looking at natural compounds, particularly ones similar to nisanolide, and sildenafil, to see whether they might act as MOAB inhibitors. And the idea is to not just replicate existing drugs, but to explore natural chemical space and identify compounds within naturally occurring substances, like let's say green tea extract. And these compounds could potentially serve as alternatives or complements to existing drugs, such as safinamide. That shifts the project from simple testing into a specific and targeted exploration. To carry that out, the project follows this structured workflow. I start by collecting compounds from databases and then natural compound libraries. Then machine learning is used to filter out these compounds based on relevant features. After that, molecular docking is used to evaluate how strongly those filtered candidates would bind to MOAB. Finally, the results are ranked so that the strongest candidates stand out and can then be recommended for wet lab analysis. Each step builds on the previous one, making the overall process much more efficient. To make that workflow possible, I use several tools. AutoDoc is used for docking simulations. Python is used for data processing and analysis, and databases like ChemEMBL provide compound data. Visualization tools help interpret how molecules interact with the protein, such as AutoDoc tools. And each of these tools handles a specific part of the pipeline, and together they allow the project to function. When everything is combined, AI's role becomes very clear. It reduces complexity. There are far too many possible molecules to evaluate manually, so AI filters and prioritizes them. It doesn't replace scientific reasoning, but it does make the process far more manageable by narrowing down the search space and focusing attention on the most promising candidates. As the project runs, it produces both inputs and outputs that can be analyzed. The inputs include natural compound structures, the MOAB protein structure, safinamide as a reference, and the outputs include docking poses, interaction details, and binding affinity scores. These results make it possible to compare compounds directly and decide which one form the strongest computational standpoint. This matters because it changes how drug discovery can be approached. Instead of relying entirely on long experimental cycles, researchers can test ideas computationally beforehand. That reduces costs, it saves time, and it allows for a broader search. In this case, it also opens the possibility of identifying natural MOAB inhibitors that might otherwise have been overlooked. At that point, it's important to step back and look at the motivation behind the project itself. This started from a genuine interest in neuroscience, especially how chemical interactions in the brain can relate to disease. Parkinson's stood out because of a connection to dopamine regulation. And at the same time, it isn't just something I'm doing casually. I also want to work and make this develop further into something publishable, so it sits between personal interest and a more serious research goal of mine. That motivation builds on the skills I've developed over time. Through AP research, I worked with large data sets. I cleaned them, I ran analysis, and that directly applies to handling molecular and chemical data. The biomedical pathway at my school, ran through PLTW, gave me a structured understanding of biological systems, from basic principles to more advanced topics like biotechnology. And then my school offers a computer science pathway, and in that there's AP Computer Science A, which helped me with the programming side of things, especially when working with Python. And on top of that, I had to independently learn some organic chemistry concepts in order to understand how the molecular structures might influence behavior when docking. The way this project actually started also reflects a progression. My teacher introduced me to molecular docking through a structured set of possible documents from different diseases in the form of a Google Doc. It was meant to be just like, hey, here's some experiments you can run on AutoDoc Vina to get you started. From there, I chose Parkinson's because of my interest in neuroscience. And instead of following the original structure exactly, which would have just been running MOAB with safinamide, I expanded it by adding machine learning and shifting the focus towards natural compounds, which hadn't yet been discovered, to work. That turned it from a basic assignment into something more closer to independent research. That process was also supported by external help. My teacher guided me through the direction of the project. She suggested where to find data sets and provided feedback as I worked through the methodology. Access to resources was also really important. My laptop actually can't run Autodoc Vina, so I didn't originally have any devices capable of running the tools. So being able to borrow a school laptop from her made it possible to carry out the work instead of just like planning it and running through it in my head. Another influence came from a friend who worked on a research proposal involving marine-derived compounds targeting BACE1 for Alzheimer's disease. His work was focused on a computational methodology, and it just proposed that you could combine docking and machine learning. And I use that as a reference to understand how my own project should be structured. And I used him. We sort of bounced ideas off of each other when eventually it led to me adapting that approach in order to fit my focus with Parkinson's and MOAB. And that step was important because it helped me move from just using tools to designing a whole research process. Overall, this project reflects not just interest, but also skill development and a lot of external influence. I couldn't have done it without the strong support system I have at my school. And it also shows that it's not just about applying AI, but using it in a way that connects to a real scientific question. And that intersection of AI, biology, and chemistry is what makes the work meaningful. And that's what I want to continue exploring moving forward.
Thank you, Fikar. I think the important part there is that he had support of teachers and people like me and peers, and that peer network is a cool part of our program, but you can also set that up with clubs and other support systems at school. Milana, you're next. And we're going to see something that many teachers could implement even without a high degree of technical competence. So here we go.
All right, hello everyone. I'm going to go share my screen right now. All right. So, hello everyone. My name is Milana. I'm in grade 10. I live in Miami, Florida, and I attended the boot camp in 2024 in Northeastern. So, just some stuff about me is I founded a student-led networking initiative for students, high school students all around the world to learn how to reach out, how to network, how to use LinkedIn, all those fundamentals. So by the end of the course, my goal is for them to at least have one call or an internship or some shadowing experience. I also love helping out the community. I have 500 plus community service hours, and I'm also Microsoft certified. And the reason I attended boot camp was because back in 8th grade, I learned about AI through Model UN. And I had very limited knowledge about this. So going into 9th grade, I knew I wanted to do something about it, which is why I applied. And it was amazing, and I don't regret it at all. So, an AI concept that I find particularly useful is sensors and machine learning, which any teacher can implement this, and I'll show how. So, sensors are devices that detect physical signals from the world and convert them into data a computer can work with. Basically, it's like a bridge between the physical environment and the digital systems, right? We use sensors, whether it's telescopes, thermal cameras, chemical detectors, photos. Basically, we're essentially giving computers a way to perceive the world, but perception alone isn't enough. A computer can collect millions of data points, but it all needs a way to interpret it, which is where machine learning comes in. Sensors generate the raw data, and machine learning turns that data into understanding. And machine learning is a subset of artificial intelligence, and the models learn patterns without being explicitly programmed. So, the relationship. For starters, the sensors collect the information. A telescope captures light from a distance. And an example of this is if we've ever heard of the James Webb Space Telescope, it collects millions of space photographs, far more than any human can analyze manually. And if scientists had to inspect every image themselves, then the programs and all the photos would be painfully slow, which is why the sensors first collect all the informations, they capture all the photos, and then the computers store and process all the photos, which are like all the galaxies, all the gravitational lensing, all that. And number three is the machine learning models analyze the data by looking for patterns and they classify the objects. So instead of a human scanning millions of images, a machine learning model can process that in minutes and highlight the ones worth studying. And collecting data with sensors and training a model to like recognize patterns is the exact same process of the thing that we're going to be doing right now, which there is an AI machine learning model any teacher can use. It's called Teachable Machine. And I'm going to share my screen right now on how I will use it. And I had an example of using brain scans to detect cancer. However, a teacher can use this for anything. They can use this maybe if they're teaching a botany class to identify different plants, different flowers. So I'm going to right now share my screen to the actual model I have. All right. So right now I'm going to go on Google to Teachable Machine. For some reason, it's not making me make my screen bigger, but that will do. So basically on Google, you can just Google Teachable Machine and you'll be brought to this website, which is loading. And then you can just click Get Started and Image Project Standard Model. You can make as many classes as you want. For example, I'm going to show you the example that I have with different brain scans. And also, I recommend having a class where it's just, let's say you're doing different flowers, have a class that's like not a flower, maybe like a caterpillar, so we can train the AI better. And it could be about like anything you want, like I said. And all you have to do is just upload your images. You can name your classes. So, like, I can say like brain, and then you just have to train the model, and then you could input photos. So, over here is my teachable machine where I did this on my own time because it kind of took a while to train the model. So notice how many photographs I have of each brain tumor. So whether it's in the pituitary, the meningioma, no tumor, or the glioma, right? This is kind of like my control. And the more images, the better, because then it trains the AI more. So it's not really that much confusing it. So now that I have my trained model, I can input photos and it will tell me which like where's the tumor. So I'm gonna go get a photo right now. And let me go to, for example, this one, the one that's over there. It knows that it's a glioma, right? And let's say I want to put in a photo of meningioma tumor. It knows it's a meningioma. Like I said, for you to have these results, my recommendation is to have as many like image samples as possible, just so, the AI doesn't confuse one for the other. And this can be used, like I said, for anything. It's called Teachable Machine, and whatever and yeah, it's very, I guess, how do you put this words? It's very flexible. And so now back to my slides. You guys can see that. What the AI is doing is it's handling the part of a work that a human would take a long time to do manually. So the AI is doing it in seconds, like you saw. And the data depends on like which model you use, but it always comes from sensors. So we're pretty much inputting this data and it's as machine learning, right? And as someone who doesn't have that much experience coding AI, this was what really like sparked it because what excites me about this is it's a step towards building my own goal of making like a machine learning model that can identify and track cruise ships all around the world because that's one of my passions. But a student can do this for anything. And basically the goal is to just help students understand how machine learning works by letting them collect their own data, train a model, and test real-time predictions using a webcam, microphone, or image filings. So this is like another model that I did. They can do it about anything you want just to show how flexible it can be. So what can a teacher like do to help a person like me? And I just want to say, like, when I was a student at Bootcamp, I became really interested in data science and machine learning after doing this project. And when I told my mentor this, he said that there was always a way that I can enhance my model, whether that be adding more images or even coding one through Python. And or I can even not just use images, but I can use a microphone, a webcam. There's so many variants that you can do of this. And additionally, he said that if I'm up for the challenge, not only could I code a model using Python, but I could also speak with higher up with like other mentors like him, and he can go step by step on like what I can do. However, as a teacher, you don't have to have this knowledge to tell someone like a student, oh, I can help you with this. What you can do if you don't maybe not know like how to code an AI like me, right? You can tell a student interested in any AI field that there's always a way to dive deeper, right? Like how my mentor told me how there's a way that I can like use a microphone or I could use a webcam. And additionally, even if a student doesn't know how to code, there's always like other methods of using different AI models. And another thing that I wanted to say was when I told like there are many teachers and they always like anytime I told them like, "Oh, I'm really interested in this," they always kind of pivoted into a way that like to make me interested about it. So anytime like I'm really interested about a certain like AI topic, the teacher would say, "Oh, you don't have to just do this. You can like expand. So like you don't have to do about brain, you could do it about cruise ships." And I also had a teacher recommend for me to get Microsoft certified through like a program. And now because of that, I'm able to like educate other students, which is another thing that I want to talk about, educating other students, is I created OpenSeas Networking, which teaches students all around the world how to network. And I'm really proud of this because I'm soon over the summer launching my first couple groups. And it's going to be 2 week sessions every Sunday. And also the links up there, there's a QR code if your students are interested in this. And if you want any more info, you can email me. I'll drop my email down below. And the problem that I found were how students weren't taught to network or communicate professionally, at least in my school. And when I told my friend about all this I'm doing, he said, he was like, "How did you hear about this? Like, I've never heard of such a thing." So, because of that, now I want to teach other students around the world. And yeah, I'm really excited about this. We're soon launching. And if you have any students interested, they can easily contact me or do the form. We're launching our first small group soon. And yeah, that's pretty much my takeaway. If you have any questions, please let me know. And yeah.
Thank you, Milana.
Mhm.
Wow, this was amazing. These presentations, the three of you are very, very impressive. Have to just say that right up front. Um, but thank you for all the work that you put into your presentations. They were very, very interesting and informative. We're now, we have about 10 minutes left, a little bit more than, well, about 10 minutes. And so we do have some folks in the audience. If you have any questions, please feel free to put them into the Q&A box. Um, I will lead off with some of the questioning here um, because that's my privilege here. I get to ask the questions, which is great to start off with, which I'm excited to do because you guys are really, really inspiring. Now, I am curious. Some of your presentations, you have displayed a really, really complex and deep set of skills that you've learned. And I'm wondering if you can share a little bit. So, this is a question maybe we'll go through each of you, and maybe we can start with Trinithi. The skills that you have seem to me extremely advanced for a high school student. And so I'm wondering, what skills were you able to learn in your high school courses? What skills did you learn from the AI Bootcamp? What did you learn through your current research project, which seems like it's part of an internship or something like that? And what did you learn on your own? And so this is the kind of question I'd love to hear from all of you. But if you could just share a little bit quickly, that would be great.
Yeah. So starting off high school, I did not know much programming. So I took my first class in computer programming and algebra, honors algebra 2. And I think that started me off with like data analytics and kind of understanding how like Java works. So that built me like a foundation. And the year after, I took AP Computer Science and AP Calculus. So I think that definitely helped me understand area under the curve, which is like a really important topic in calculus. And also, I did a bunch of certifications, so that helped me with like data analytics, cybersecurity, AI, just learning everything about that. And most of it was definitely self-studied because I wanted to just kind of deep dive into a bunch of different computer science topics because that's what I'm going to major in. And I just thought it was good to have like a well-rounded perspective on computer science from everything from hardware to AI and everything like that. And I started honestly learning about AI from the boot camp itself because AI just seemed like an abstract concept and I didn't really know how anything about it worked. And then doing the computer science track within the boot camp, I think introduced me to like the CS side of AI. And then I pursued all of my 11 certifications after that. And yeah, I think it was definitely an amazing experience. And that helped me become the first IT intern in my whole school district. And I manage a lot of the hardware and the software issues in my school, and I help troubleshoot everything. So I think just learning how to communicate and just having all those skills is really essential for me personally. And the as for the research project, I was selected in a highly competitive internship program, and I was matched up with a mentor at ASU. And I was matched on my interest in immunotherapy and AI, and she kind of helped me develop this project. And I also presented this at the science fair.
Amazing. Okay. How about Fikar? How about for you? How would you describe your learning experience to be able to do what you do now?
Um, well, I guess like the earliest was it would be my sophomore year. I was taking the first time I'd ever touched any bit of code would be in AP Computer Science, and that corresponded with the AI boot camp. So that went along really well. Not that you need any coding experience with the boot camp, but it definitely helped with sort of processing everything that would happen in class. During the boot camp, I learned sort of the basics. I learned AI ethics. I learned how to train in AI, all that stuff, which I did end up using in this project. In computer science, I learned the basics of computer science, which a lot of the Java stuff carried over to Python, so that also helped out a lot. I also took AP research. So in that class, I did my own research on epidemiology and I had a large data set. So it sort of helped build my endurance with this project where I have about 12,000 different molecules to go through. So that really helped. Um, we also have a biomedical pathway, and in that, our my second year, I believe it was a human body systems course. That one really built my understanding of Parkinson's and how neurotransmitters work in the body. And then outside of school, I've been involved in a lot of clubs, but the one that helped the most would be it's called Advanced Biomedical Research Society, which is a mouthful. Um, that we tend to work with a professor in producing novel research. That helped not as much as the rest, I'd say, because at that point I had already built up the skills, but it was sort of that one I did find um, a novel bacteria which produced an enzyme, lactase, in anthills. So that one helped with like narrowing down how I can define my research question and stuff in order to find something new with my stuff. And then also the large support network, the strong support network I had. My friend, he helped me out a lot when it came to bouncing ideas off of him. My teacher, she helped me a lot with learning, like self-studying some OChem because aromatic rings, it's like part of the 3D structure or 2D structure, both of a chemical compound. And I didn't know anything about that until this project. So she helped me with that. She helped me with a lot of things throughout this course and other teachers as well. And the computer that I was able to borrow so I could actually run the docking and do all of this.
That's amazing. Yeah. Okay, great. Thank you for sharing that. How about Milana? Do you want to jump in and share a little bit?
Course. So, like I said in my presentation, starting high school, the only thing I knew about AI was ChatGPT, which is why I joined the bootcamp to begin with, so I can learn more. And after the bootcamp, I gained a lot of knowledge that I was able to share with my classmates. And additionally, I'm super excited because I mentioned this before, but I got an internship at FIU over this summer where I'll be working with professionals and professors to be able to implement AI to college students. And I showed the recruiter my knowledge gained from the boot camp, and because of that, he was really impressed. And additionally, my Microsoft certification that my teacher helped like mentor me to like get also like helped a lot in my case. And my teachers and mentors helped me a lot as well by transforming a world where like I did not know anything about AI to a world where I'll be interning AI in a couple months. So I just want to thank everyone as well, and through all the support they gave me and through all my passions.
That's amazing. Can you guys, and we'll start with you again, Milan, and then maybe we can work our way around the other direction. The supports that you all have talked about, it sounds like there have been teachers, a network of teachers as well as peers. Is that correct? And so can you talk a little bit more? Are these the teachers from your school, from your classes? Are they from clubs? And Charlotte had mentioned, are you reaching out to folks at the AI Bootcamp as well? Tell us a little bit more about how you consult with all of these different supports. Like who do you consult with and where are they from?
Mhm. So, in my previous school, when I was middle school, I had a teacher who gave me all the support I needed to like my first beginning steps in AI. I necessarily didn't know about it, but I knew how to convey it now that I knew how like I can use Microsoft. She gave me like huge steps into becoming Microsoft certified by teaching me from the basics of like inserting text in Word to making whole diagrams and like all this, etc. And additionally, with the mentors, that also helped me so much, especially the ones in boot camp. And additionally, when I became a part of the welcome committee, aka I came back to boot camp again this year so I can volunteer as like a student ambassador, where I also help many students with like navigating around and making just a nice community. The mentors there and when I attended boot camp were all like so supportive. It's the matter of like if a mentor is like really passionate and like you can tell that they like love what they do, they will gladly like give you all the steps you need. And when I would tell my mentors, I'm really interested in this topic, what should I do to expand it? They would tell me, "Oh, you can go like do this abroad. Like maybe you could do even audio and stuff so you can identify different like cruise horns, right?" And just from that, I was like, my passion like completely sparked. And because of the steps that my mentor gave me, I was like, okay, I want to do something definitely about this in the future. So I'm really grateful for everything that they've done.
Great. We're almost at the end of the hour. So if we just do a really quick, if it's possible, lightning round. Fikar, can you talk a little bit about the peer support? Is it supports many peers or who
Um,
are your peer supports?
I have my best friend Yazed. He was my main peer support. Then I have sort of like three other people, my sister, my twin sister, my other friend who helped, he's also in the same pathway. And then my sister, she helped a lot with because she lives with me. She knows like my thought process. So whenever I would like overlook something, she'd be like, "Hey, didn't you forget this?" Like during this project, I forgot that I forgot one of the like a whole chunk of just molecules. I just forgot to check them. And she was like, "Hey, make sure to double check everything so you don't have to go back when you get inaccurate results." So she helped with that. My friend Yazed, he helped with the methodology. And my other friend, he really helped with not so much the methodology, but with like studying um, what I needed for this project. He also did a bit of coding. So he helped me with coding the AI to machine learn, and then he helped me with learning how to code in Python in general and that sort of stuff.
Okay, great. Well, actually, I wanted to get to this question to Srinithi as well, but we are at the end of the hour, so I don't want to keep you too late because I want to respect everybody's time. So if we can quickly, Jen, if you're able to share our final slide to close out this webinar, I want to give a huge thanks to all of our amazing speakers, our student speakers today, as well as to Charlotte for sharing all of your insights about the work that you're doing. I want to thank everyone who attended for showing your interest. For those who are in the audience, we would really appreciate your feedback on today's session. And so I think we will be posting a link to an anonymous brief 3-question survey. If you could share your feedback, it would be wonderful. If you're interested in our Teacher PD or our Career Hub of resources, please visit us at datapaths.edc.org. Again, if you have more questions, please visit the Mark Cuban Foundation website. Charlotte had shared their website earlier if you want more information about their AI Bootcamp. We will have this recording posted on our website, as well as we hope in the future clips of highlights. And so that's about it. Thank you, everybody, for attending. We really appreciate your time.
Thank you so much.
Thank you.
And I'm going to send the link to the form of my networking in the chat, so whoever wants to check it out.
Great.
Thank you.
Thank you so much, all of you.
Thank you.
Bye.
Bye.